This video is going to cover the third learning target on our unit on nonlinear functions. This learning target talks about transforming these nonlinear functions. So we're going to look at how they get graphed and how we transform those graphs in different ways. The first kind of function we're going to talk about is the cubic function. The cubic function has a power of 3. To graph this, let's just use a normal typical list of possible x's such as -2, -1, 0, 1, and 2. Let's plug in these numbers into our function and evaluate to figure out what the y's are. -2 to the third power is -8, -1 to the third power is -1, 0 to the third power is 0, 1 to the third power is 1, and 2 to the third power is 8. Let's plot each of these and see what it looks like. -2, -8, -1, -1, and 0, 0, 1, 1, and then 2, 8. So I end up with a curve that looks something about like this. The transformational form of this would add in our a, our h, and our k that we've talked about when we did quadratics. So a times x minus h to the third power plus k. This is what we refer to as a mother function. It is the parent of all other transformations of that function. We will always graph this main mother function, and then we will move it according to the way that the a, the h, and the k affect it. Our second mother function is y equals absolute value of x. So the name of this mother function is absolute value. And we're going to use the same list of x's as we did before. So -2 plugged in, the absolute value of -2 is a +2. That's what absolute value does. It is the full positive version of any number. -1 absolute value would just be +1. The absolute value of 0 is still 0. Since 1 is already positive, the absolute value of 1 is still 1, and the absolute value of 2 is still 2. Basically, absolute value gives you all positive values. So let's plot each of these. -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. So we end up with this very V shape to our graph. It is not a parabola, it is more like a V. The transformational form is very similar to the transformational form for cubics. It is y equals a times the absolute value of x minus h and plus k. Again, remember, this is a mother function. Our third mother function is a square root function. We're going to use the same -2, -1, 0, 1, and 2. Now, if I did try to use these, I would end up with some pretty funky numbers. First off, we cannot square root a -2 or a -1. If you tried to square root -2 or -1, you would get an error. You can square root 0, it is just 0, and the square root of 1 is 1. Now instead of square rooting 2, which would give me some decimal I'd have to deal with, how about we square root something that we know there is a nice square root of, such as 4. The square root of 4 is 2. So now let's plot each of these. Our first point is at 0, 0. Our first point is at 0, 0. Our next point is at 1, 1. Our next point is at 4, 2. If we were to square root 9, we would get 3. So I end up with a nice kind of general curve as it continues up and over to the right. The transformational form of a square root function is y equals a square root of x minus h plus k. Be very careful that you make sure that the minus h with the x is underneath the square root sign, and that the plus k is not underneath the square root sign. It would come after. Remember, this is called a mother function. We graph these before we graph any kind of transformation. Let's talk about h, k, and a. Remember from quadratics, the h is always subtracted from the x in every single one of the transformational forms, and it controls the shifting from left or right. For example, if we had y equals x plus 3 squared, the transformation would shift the graph 3 to the left. K is always added at the end of each of the transformational forms. It controls the up and down shift. For example, y equals the square root of x minus 4 means this shifts this 4. Pay close attention always to the fact that when you're dealing with h left and right, you're always dealing with opposite signs. A, remember when we did it with parabolas, allows the parabola to become narrower or wider. This affects other types of nonlinear functions in similar ways, but one thing that's very important to know is that if there's a negative a in the front, even if it's a -1, it's going to flip the graph, basically become a reflection of the graph of the mother function. For example, y equals -3 absolute value x would flip the graph because it has a -3, but it would also make it a little bit more narrower. So as we do these types of problems and as we do these types of graphs, let's try to be organized about it. And let's always draw the mother function in red and then graph our transformation of that mother function in normal pencil, gray, or black ink. Let's try doing one of these transformations. Y equals the square root of x minus 3 plus 2. First, let's identify what the mother function would be. The mother function would be basically just your x and your y with any kind of operation on it. So our mother function in this case is y equals the absolute value of x. What is the types of shifts that are going to happen to this? Well, the first shift is going to be a 3, but remember it's always x minus h, so this is a shift of 3 to the right, not left. And the other transformation in this problem is a plus 2. That's our k, it's up or down. Since it says plus 2, it's going to be 2 up. So first let's copy the mother function for y equals square root x that we just did a moment ago. Here we go. And now let's take each of those points that we plotted and shift them according to the h and the k. So our 0, 0 point is going to shift 3 to the right, 1, 2, 3, and 2 up, 1, 2. Our 1, 1 point, same thing, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and 1, 2, 3, 1, 2. There we go. So our red graph is our mother function, y equals square root of x, and our black graph is the graph of the actual function that we're concerned about, and that's y equals x minus 3 square root plus 2. In this example, we're going to graph and transform an absolute value function. As I look at my function that is given to me, I notice that we have a few things to keep in mind. We have a plus 1, we have a minus 3, and we also have a negative to consider. If we eliminate all of those pieces
from the function, what's left over is just an absolute value x. This is the mother function. So this function is going to move 1 left, because remember it is x minus h, so this is actually a negative 1. It's going to go 3 down, and it is going to get flipped. And it's going to get flipped over the x-axis. So let's plot the mother function. The mother function can be found on the previous screen for y equals absolute value of x. The points for that was 0, 0, 1, 1, 2, 2, and you can continue that pattern all the way up. Negative 1, 1, negative 2, 2. And let's put in some nice lines. There we go. So now it's time to take each of these points and move it. So first up, let's move the 0, 0. It's going to go 1 to the left, it's going to move 1 to the left, it's going to move 1, 2, 3 down. So now it is 3 away from the x-axis, so it's going to flip to be 3 away, 3 above the x-axis. Let's move our 1, 1 point. Again, it's going to go 1 to the left and 1, 2, 3 down. It is now only 2 spaces away from the x-axis, so I'm going to flip it so it's 2 spaces above the x-axis. Let's try moving negative 1, 1. 1 to the left, 1, 2, 3 down. It is now 2 spaces from the x-axis. Flipping it will put it 2 spaces above the x-axis. I can now start to see the shape of this. The V is now starting to look upside down, and it has moved according to the H and the K. And there you go. So that's what it looks like when we have negatives in front of our mother functions. And this is what we do when we have H's and K's to shift left and right and up and down. Remember, if you have questions, make sure you write them down in the left-hand column of your notes so that when you come into class, we can discuss them. You can also shoot me a message right away using our Remind text messaging service if you have questions, right away. Otherwise, I look forward to seeing you guys back in class.